In this session, we will see how to build a model of a robotic arm. What is a robotic arm? Is it the arm of a robot that you've seen as a toy or in a movie? In general, a robotic arm is a mechanical arm which performs operations much like a human arm. The robotic arm is the most commonly used robot in manufacturing industries. It is controlled by computers and programmed to perform a variety of operations, like car painting, welding, picking and placing objects, and so on. The arm is actually an assembly of several different parts, like the base, shoulder, arm, and gripper. So let's try to model this robotic arm. Does it look difficult? Don't worry. We'll model only a few components and assemble the remaining ones. Let's start with the base part of the arm. First, let's analyze the shape and plan how to build this model. Look at the technical drawing of the base part. It looks like the base part is made up of a cylindrical portion and a rectangular slab connected on one side. The cylindrical base and the rectangular slab have different heights. We can first sketch the base circle and pull it. Notice that the base has a taper, so we'll have to use the draft feature within the pull tool. Next, we can create the slots on the base. It looks like the slots are in a circular pattern. So we can create one slot and then use the pattern tool to create the remaining ones. We can also see a couple of cylinders mounted on top of the base. We can quickly sketch the circles and pull them. This will complete the cylindrical portion of the base. The remaining part to be modeled is the rectangular slab. It also looks pretty simple. Create a base sketch and then pull it. In the drawing, we can see that the side faces are also at an angle. So once again, we'll have to use the draft feature to create that taper. The last step would be creating the chamfers. Alright, it looks like we have a plan in place to build this model. First, we'll model the cylindrical base, then create the pattern slots, followed by the cylindrical mounts. Lastly, we'll create the rectangular slab, and then the chamfers. Let's get started. Orient the sketch in the plan view by pressing the letter V on the keyboard. Then begin sketching a shape on the XY plane. Select the circle tool and place the center point at the world origin. Then give it a diameter of 780 millimeters. Return to 3D mode, then press H on the keyboard to reorient the view. The drawing shows that the height of the base is 170 millimeters, which includes 20 millimeters for the slot height at the top. So the height of the base cylinder without the slot becomes 150 millimeters. The pull tool should already be active. Select the circular profile and give it a height of 150 millimeters in the positive Z direction. The front view in the drawing shows that the taper angle is 95 degrees from the horizontal axis. With the pull tool still active, select the side cylindrical face, then click the draft option in the pull tool menu. Select the bottom circular face as the plane to draft about, and drag the side face inwards -5 degrees. We've now created the tapered base. That was really easy. The next step is to create the slot and its pattern. Select the top circular face, then go to the plan view and switch to sketching mode. Select the line tool and create a line from the center at an angle of 5 degrees to the outer edge of the circle. Similarly, create one more line from the center at an angle of 5 degrees on the other side of the x-axis. The drawing shows that the inner face of the slot has a radius of 290 millimeters. In the sketch tools, select the Sweep Arc button. Select the origin as the center point and move the cursor over any of the lines created earlier. Specify a diameter of 580 millimeters to define the starting point of the arc. Then sweep the cursor and click on the second line to complete the arc. The segment of lines meeting at the origin is not needed. Select the Trim Away tool and click the lines to trim them. The sketch of the slot is ready now. Return to 3D mode and press H for the home view. Activate the pull tool and select the face of the slot, then pull it up 20 millimeters. You'll notice that the outer face maintains the taper of the bottom cylindrical face. That's pretty cool, isn't it? Now let's pattern this slot. Select the circular pattern tool. Click and drag a box to select the 3 side faces and the top face of the extruded portion we just created. Select the direction option from the circular pattern tool menu and select the tapered cylindrical face. In the pattern options panel on the left side of the screen, set the circular count to 20 and press enter. You should see a preview of the pattern that's going to be created. Finally, click the green check mark to complete the operation. Next, the drawing shows that we need to create the 2 cylinders located above the base. Select the top circular face and start the circle tool. Press the letter V to orient to the plan view, and then create a circle at the center with a diameter of 360 millimeters. Start the pull tool and pull the face up 100 millimeters. The drawing shows that the side face of this cylinder is also tapered. With the pull tool active, select the side cylindrical face. Then select the draft option and choose the top face as the plane to draft about. Enter a value of 5 degrees and press enter. Press S on the keyboard to exit the pull tool. Then choose the top face of the new cylinder and click the circle sketch tool. Reorient to the plan view and sketch another circle in the center with a diameter of 300 millimeters. Pull this new face up 30 millimeters. This completes the cylindrical section of the base. Let's proceed to modeling the rectangular section. Select the bottom face located on the XY plane and start a new sketch. The bottom view in the drawing shows that the outermost face of this rectangular section is located at 650 millimeters from the center of the cylindrical base. Select the line tool and activate the option Define Line from Center. Place the cursor on the world origin, and without clicking, tap the Shift key to activate the reference dimensions. Once the reference dimensions are activated, move the cursor towards the left and specify a horizontal dimension of 650 millimeters. Make sure the other dimension value remains at 0. The starting point of the line is now fixed. Create a vertical line of length 550 millimeters. Now clear the option Define Line from Center and create 2 horizontal lines from the endpoints to the base of the circle. Double-click to start a new line segment. The base sketch is now ready to be pulled. Switch to 3D mode and start the pull tool. Select the profile and pull up 100 millimeters. Notice that there's a gap created between the rectangular slab and the circular base region. This gap needs to be filled. Select the cylindrical face of the extruded slab and pull it towards the circular base, such that the slab overlaps the base. You can see that the gap is now filled, and the rectangular slab is in perfect contact with the circular base. The drawing further shows that the side faces of the rectangular slab are also tapered, making an angle of 95 degrees with the horizontal plane. So with the pull tool active, select the 3 vertical side faces. Then click the draft option and select the base face as the plane to draft about. Enter a value of -5 degrees. The last step is to create the chamfers along the outer edges of the rectangular slab. Start the pull tool again and select the 3 straight edges on the top face and the 2 vertical edges on the outsides. Remember to hold Control to select multiple items simultaneously. From the Options panel, select Chamfer and enter a distance of 20 millimeters. This completes the modeling of the robotic arm base. Let's create a component for this body. Components are very useful when working with assemblies. In the structure tree, right-click on the solid body and select Move to New Component. Name the new component Base and press Enter. Now, let's import one assembly that is located over the base part that we just modeled. Go to the Assembly tab in the ribbon and select the File button. Navigate to the folder where Robot Arm Unit 1.stp is saved. To see the file, select the step format from the list of formats. Select the STP file and import it. You can see that the imported assembly is transparent. This transparency usually indicates that the bodies are not solid. Unlike solid bodies, surface bodies don't have any volume associated with them. Let's hide the base component to get a better view of the imported assembly. In many cases, if an imported model is made up of surface bodies, then that model needs to be repaired. In simple terms, repairing surface bodies means creating a fully enclosed volume by stitching the surfaces, closing gaps, or repairing missing faces. Let's perform these operations on the imported model. Go to the Repair tab in the ribbon and click the Stitch tool. Edges that need to be stitched are highlighted in red. Click the green check mark to automatically complete the operation. Next, select the Gaps tool. There are no gaps reported between the surfaces in this model. Click the Missing Faces tool. It highlights a couple of regions where the faces are missing in the model. Click the green check mark to complete those missing faces. The model now becomes opaque, indicating that the bodies have been converted to solids. Zoom into the top portion of the component support unit. Located within the imported assembly, we can see a circular face. However, the cylindrical bar, as seen on the opposite side, is missing. Let's create this missing bar. Go back to the Design tab in the toolbar and start the Blend tool. Hold Ctrl and select the two circular faces. Click the green check mark to create the cylinder in the preview. Now, zoom back out and turn on the display of the base component. The imported assembly needs to be placed over the top face of the base with its axis aligned with the axis of the base. Go to the Assembly tab, select the base component from the structure tree, and then click the Anchor button. This will fix the location of the base component so it can't be moved. Next, select Align. Now, select the circular face on the bottom of the imported assembly and the top circular face of the base component. The imported assembly aligns itself with the base face. If you rotate the model to view it from the bottom, you can see that the axis of the imported assembly is not aligned with the axis of the base. With the Align tool still selected, click the side cylindrical face of the imported model, and then the cylindrical face of the base component. The axes now get aligned with each other. The imported assembly is now perfectly aligned with the base component. Let's now try to model the Arm 1 component of the robotic arm. For convenience, a partial model has already been created for you. In the Assembly toolbar, select the File option. Navigate to the folder where arm1.scdoc is located. To see the file, make sure that SpaceClaim files are selected from the File Type menu. Select ARM1 and click Open. The ARM model is imported at the correct location and doesn't need any alignment or rotation. We now need to build the remaining part of the model. Let's first analyze the shape and plan how to build the model. Let's look at the technical drawing of this part. It looks like there is a section similar to the one that we imported. The base circular portion is different from the imported one and has an angular section, so we can copy the imported section. Both sections are connected to each other, so we can sketch the part to connect the two outer sections. Next, the circular section of the component that was copied needs to be edited to create the angular portion. This can be easily done by creating a sketch based on the dimensions provided in the technical drawing. The last part is to create a connecting rod at the top. So we have a plan to build this remaining portion of the model. Copy the imported component, connect the two components, create an angular section for the copy, and finally create the connecting rod. We've planned how to make this model, so let's get started. Looking at the left view in the technical drawing, we can see that the thickness of the imported component is 60 millimeters, and the gap between the two sides is 166 millimeters. So we need to copy the first side and move it a total of 166 plus 60 millimeters, or 226 millimeters. In the structure tree, hide the base and robot arm unit 1. Right-click arm 1 in the structure tree and select Activate Component. Start the Move tool and click and drag a box to select the solid body in the window. While holding Control, click the handle that corresponds to the Y direction and drag it. Enter a value of 226 millimeters and press Enter. Now that we've duplicated the side of the arm, let's create the connecting body between the two sides. Click the rectangle sketch tool and place the sketch plane on one of the planar vertical faces of the arm. Set the plan view and set the starting point of the rectangle to the inside corner at the top of one of the vertical faces. Create a rectangle that's 166 millimeters wide by 630 millimeters long. Start the Pull tool and select the newly created rectangular profile. Rotate the model to the opposite side and click the Up To option from the Pull tool menu. Then select one of the curved faces at the back of the arm as the target object. This should automatically combine all three bodies. If we look at the right view of the drawing, we can see that the thickness of one side of the arm is different from the other. The dimensions tell us that the thickness is 106 millimeters, so we need to add 46 millimeters to this side of the arm. Select the inside face and pull it 46 millimeters. We now need to create the angular section at the bottom. Select the outside face and switch to sketch mode. The drawing indicates that the outer circular section has a radius of 82.5 millimeters. Start the Circle tool and hover over the edge of the circular section to locate the center point. Then select the center and create a circle of diameter 165 millimeters. From the drawing, we can see that the two angular lines are tangentially connected to this circle. Select the Tangent Line tool. Then select any location on the left side of the circle to define the start point, and place the end point where the outer circle meets the vertical face. Click on the other side of the circle, and then click anywhere on the vertical line. This will display the angular dimension for the line. The drawing tells us that this line is at a 50-degree angle with the horizontal line. Enter a value of 320 degrees. This will move the line, and you can notice that the endpoint is no longer on the vertical line. The endpoint needs to be on the vertical line. We can adjust this using the Create Corner tool. First, select the line that's at an angle, then select the vertical line. The line segments highlighted in red will be trimmed away. Use the Trim Away tool to delete the inner circular arc between the two lines. Last, create a circle with diameter 450 millimeters. Switch to 3D mode. If we look at the drawing, we can see that we need to remove the region outside of the angular section. Start the Pull tool and select the outermost face and the small corner for pulling. Pull the two faces 106 millimeters to completely remove the material. Looking at the drawing again, we can see that the angular section only has a thickness of 35 millimeters. Use the pull tool again and select the remaining face and pull it -71 millimeters. There's a 20 millimeter chamfer at the outer edge. Select this edge and then click chamfer from the pull tool options. Press the spacebar and enter the value of 20. This completes the bottom angular section of the arm. The next step is to create the connecting rod at the top. Zoom in at the top of the model and select the two inner faces and start a sketch. A sketch plane will be created at the center of the two selected faces. Go to the plan view to orient the sketch and select the Project to Sketch tool from the toolbar. Select the outer edge of the top circular face to project it onto the current sketch plane. This will give us the center location for a new circle. Start the Circle tool and move the mouse cursor over the projected curve. This will locate the center point. Click the center point to place the new circle and enter a diameter of 60 millimeters. Switch back to 3D mode and delete the extra curve. Referring to the drawing once again, the total length of the connecting rod comes out to be 570 millimeters. Using the pull tool, select the circular face and enable the option Pull Both Sides. Then pull the face 570 millimeters. Right-click the top entry in the structure tree and select Activate Component. Then right-click in the background and select Show All. The last step is to create the shaft holes for the arm body. Zoom into the middle of the model. Go to the Prepare toolbar and select the Interference tool. This will highlight a couple of locations. In the Options panel on the left, enable the option Subtract from Smaller Body. Then click the green check mark. The shaft holes get created in the arm body. To complete the assembly, we need to add the remaining components of the full robotic arm. Go to the Assembly tab and click the File button. Locate the SpaceClaim file named Robot Arm ASM and open it. The items in the structure tree with a white page or document icon behind them are external components. This means they are stored in a separate file that is not the same as the main assembly file. Right-click the top entry in the structure tree, then click Source, Internalize All. This will copy the geometry from the external file and consolidate the information within the main assembly file. It's a good habit to internalize these types of files as soon as you import them. Remember to save the assembly before closing it. Congratulations! You've completed the design of the robotic arm.